Support. Today we are discuss about the topic notes on Nernst Distribution Law. What's the definition and the statement of Nernst Distribution Law? First one, the definition. The distribution law, or also known as Nernst Distribution Law, describes the equilibrium distribution of solute between two immiscible solvents. Then what is the statement means? At a constant temperature, if a solute, that means X, distributes itself between two immiscible solvents in contact with each other, then that equilibrium, the ratio of concentration of solute in two solvents is constant. Mathematical expression, C1 divided by C2 equal to Kd. C1, that is the concentration of solute in solvent 1. C2, that is denoted as concentration of solute in solvent 2. Kd, distribution coefficient or partition coefficient. Important conditions and assumption of Nernst distribution law. For the law to hold true, the following conditions must be met. Constant temperature, immiscible solvents, same molecular state, direct solution. First one, constant temperature. That is, Kd is temperature dependent. Immiscible solvents, that the two solvents, example water and chloroform, water and ether, must not dissolve in each other to any appreciable extent. Same molecular state, that means the solute must have same molecular formula and state. In the both solvent, it should not dissociate and associate or react with either solvent. Then direct solution, the concentration of solute, that is should be low. Distribution law. The distribution law fails when basic assumptions are violated. The key limitations are: first one, association of solute in one solvent. Problem, if the solute molecules associate in one of the solvents, its effective concentration changes. For example, benzoic acid in water exists as single molecules, but in benzene it dimerizes. Then the simple uh, concentration water divided by concentration benzene ratio is not constant. Modification, the law can be modified to account for this. For dimerization, the relationship becomes concentration of water divided by root of concentration of benzene is equal to constant. Of solute in one solvent. Problem, if the solute dissociates into ions in one solvent, the total concentration does not represent the concentration of the simple molecules. For example, when succinic acid distributes between water and ether, it's partially dissociate into ions in water. The simple concentration ratio is not constant. Modification, the law is applied to the concentration of undissociated molecules in the solvent only, but dissociation occurs. With the solvent, if the solute chemically reacts with one of the solvent, its molecular state is altered. For example, the distribution of iodine between water and carbon tetrachloride is normal, but if we use an aqueous potassium iodide solution instead of pure water, the iodine reacts to form the triiodide ion. This changes concentration of free iodine molecules in aqueous layer, and a simple concentration water and carbon tetrachloride ratios fails. The law is strictly valid only for dilute solution. At high concentrations, the solute interactions become significant and behavior deviates from ideally. Applications of distribution law. First one, solvent extraction. That is the extraction process. This is one of the most important industrial application. It is used to separate or purify a solute from a mixture. Principle: a, a solute is more soluble in one solvent than another. By shaking the mixture with the extracting solvent, the solute transfer into it. The process the process is often repeated multiple times with the fresh solvent to achieve higher efficiency. Well, extraction of organic compounds from aqueous reaction mixtures using ether or dichloromethane. Extraction of iodine from water using carbon tetrachloride. Purification of antibiotics and other equilibrium constant. The distribution law can be used to find equilibrium constant of a reaction, particularly dissociation. For example, determining the degree of dissociation for a solute that dissociate in a solvent 1, that is a water, but not a solvent 2, that is a organic solvent. The distribution coefficient can be used to calculate the degree of dissociation in solvent. Test for chemical reaction. As the seen in the limitation, if the observed distribution ratio does not match the expected partition coefficient, it indicates that solute is undergoing a chemical change in one of the solvent. Determination of molecular state. By studying how distribution coefficient changes with concentration, we can reduce the molecular state of the solute. Example, if the experimental data fits concentration 1 divided by concentration 2 equal to distribution coefficient, the molecular state is the same. If it fits concentration 1 divided by root of concentration 2 is equal to constant. That solute demineralizes in the second solvent. Partition chromatography. This is a cornerstone analytical technique. Example, paper chromatography, HPLC. The principle, the separation of components in a picture is based on the different distribution coefficients between stationary liquid phase and mobile liquid or gas phase. The component with a higher affinity for mobile phase move faster. Solvent extraction. Most important application to separate or purify a solute from mixture, that is extracting organic compounds from water using ether. Partition chromatography separates components based on the different distribution coefficients between two phases. That means pop-up chromatography, then HPLC. Drug design using a octanol water partition coefficient to predict a drug's absorption and membrane permeability. Determining molecular state to find if a solute associates or dissociates by analyzing the distribution ratio. That is the applications of Nernst distribution law. Thank you.